Hi guys, welcome to another video of Python tutorials, and today we're going to discuss about multi-threading in detail. Okay, so in general, all the process or all the lines of code that you execute works in a sequential way. That means one after the other, and you know pretty well that why that is happening because of the existence of a mechanism called GIL, Global Interpreter Lock. Because of this specific mechanism, what actually happening is that every time when you try to run a code, it runs sequentially. Okay, at times I have to deviate from this mechanism. In that case, I may want to execute code parallelly, concurrently. Okay, in that case, what I have to do? I have to do the normal way of code execution in a other way. Okay, so now today in our demonstration, right, I'm going to take you people to a shortest of code where I'm going to make that as a sequential program initially, and I'm going to slowly convert that into a multi-threading. While doing so, I'm going to teach you about different, multi-threading concept, and also I'm going to tell you about the detailed difference between the multi-process and concurrency. If somebody tells you that multi-process and concurrency are two same thing, don't accept the wordings, okay? Because multi process is different. That means parallelism is different and concurrency is different. And again, I'm repeating, guys, parallelism is different and concurrency is different. Okay. And also, when we execute the code or when we execute a set of operation, there is always those codes tend to work in two different areas. One, certain code will be bound on the CPU. That means it may run on your CPU bound or sometimes run on their input output bound. So that means basically programs are hardly categorized to is like CPU bound and input output bound. Okay, so which one to use here? What is parallelism here? What is concurrency here? What is threading, by the way? We're gonna see that in detail right now. Okay, so now first I'm going to take a normal. First, I'm going to take a normal multi-threading concept using a user-defined function. Okay, I'm going to take user-defined function. So let me just declare function 1 without any argument, and I'm going to have print like 1, and I'm going to just take a time module for the better viewing of or the better result to show whether it is running sequentially or parallelly. So let me take time. So time dot C time. You know very well that when I want to use the time model, I need to import that. So import time. Okay. Similarly, I'm going to execute another function of name called to with some output for that. Print time dot C time. So what might happen when I execute these two, functions? You know that function 1 will execute first and then only function 2 will execute. So I was thinking that maybe if I add a time, it will show you the difference that it is running sequentially. So when I run, look at that, both runs at the same time. So never and ever think this is a result, because just because it is running on the same time or just because it is executed on the same time doesn't mean that it is running parallelly. Every code in Python usually, again I'm repeating, every code in Python usually runs with the nanoseconds of difference. So when you run this kind of a function as it is, will not guarantee you that whether it is a multi-process or a sequential process. So now to have a better clarity, I'm going to put some delays. Time dot sleep of delay. Delay indicates two indicates here seconds, so 2 seconds. So I'm basically making my one function to execute at one time, and then it have to wait for 2 seconds. So now the real question is that we need to find whether function 2 is waiting for the 2 seconds to get completed or the second function is getting parallelly executed. So when I ran, look at that, it executed at 26:43 seconds, and whereas another function got executed at 26:45 seconds. So basically there is a 2 seconds delay. So now this is the evidence and this is the proof that yes, Python by base works sequentially. So in order to have a multi-threading incorporated here, or in order to have multi-threading as part of this, right, what we supposed to do is that we're gonna include a multi-threading process. As of now, I'm gonna teach you multi-threading and then I'll tell you the drawback with the multi-threading and I'll tell you what you're supposed to do to avoid this. Okay, now I'm going to exactly change the same function but to execute in a different threaded way. So first thing, I'm not going to use a normal function calling. That's very much clear. Okay. Now I want to use a library. For that I need to use or I need to get certain library that is going to help us in achieving this multi-threading. So import threading. So this is the library that I'm going to use it or my program is going to use this for executing the things parallelly or concurrently that you can conclude it later. Okay. So now since there is two function, I have to execute two number of threads. So first, let me create two threads. So just for the better understanding, I'm just creating it as T1 and T2, and it is up to you to name whatever the thread you want to name. So T1 is equal to threading, the library that I've used on the top, followed by the thread function. Here, same thing, threading dot thread. So now what happened? There are two threads that have created basically here. Okay. And what I supposed to do? See, just because I bought a car doesn't guarantee that I can able to drive. So I need to drive it. Correct. Same thing. Just because you created thread doesn't mean that it will run. So what you supposed to do? You need to start both the threads. You need to start both the threads. That I'm pretty much clear. Now you created a thread and you're going to start a thread, but you need to set the target. You need to set the destination that these two threads need to achieve. So first thread is going to target a function one. So the syntax is this: target is equal to 1 and target is equal to 2. So basically this is the syntax where you need to tell what function that the multi-threading is supposed to target. So T1 targeting function 1 and T2 is targeting function 2. Okay, now instead of you having a default statement in a print on both function 1 and function 2, you can have something that is going to be passed as an argument. How do you do it? This one, look at that. Just put a variable as a name. Just put a variable as a name. You know that when a function operation takes certain name, the same name should be there in your function definition. So declare that as an argument. So basically what both my function 1 and function 2 trying to take one name as an argument. So now what is the additional duty that you're supposed to take care here? During the execution of T1 and T2, you need to put this argument as a part of it. So how do you pass? You should not be passing the argument in a conventional way. You're supposed to pass it via this syntax. Args is equal to, similarly args is equal to. What was this args in the sense? Arguments. And when you pass an argument to the function via multithreading, you have to submit the argument either in the form of tuple or in the form of list. That you need to be very careful. Either it should be in the form of list or tuple. So let me pass via tuple first. Since both the function takes only one argument, let me declare it as Kohli and let me declare it as Kohli. And now what is this arguments? It look like a string. We are already discussed during our first two videos. If there is a need for us to have only one data as a part of a tuple, it is mandatory that you need to add comma after that so that your Python will understand that as a tuple. If not, your Python will understand that as a string. So add a comma. You can do that. And if you feel that that I may forget comma something like that, better to go with list, because that list doesn't need you to have commas at all, because whatever you declare within the square braces, even if the one data, your Python is going to understand that as a list. Okay, now let me run this code. Look at that. When I run, Forget about the alignment. Okay. What you're supposed to see is that look at that. Now both Dhoni and Kohli, that means the data of two different thread is getting executed at the same time. So what basically happened is that the second thread doesn't wait for the delay to complete because I'm just kickstarting both the threads simultaneously. Okay. So this is what the basic, example that I support to tell you about multi-threading. Okay. And one unique difference that you need to find here is that look at that. This is nothing but your idle process. That means your code process, and this is your threads. So basically what happened in this particular screen or the screen that you're having a visibility right now as three threads. One is your main thread, which is your idle program, and inside the idle program you do have two different threads. So now what basically happening is that your main thread is closing before the actual multi-threading runs, because here the multi-threading starts, but before the multi-threading ends your actual thread of this main thing is getting closed. Even though this is not altering your process, here in this specific code you no need to worry. That means basically here, even if you put something like this, let me put that first. So I need to join these two threads to run in a, look at that. Now the multi-threading is done and then only your main thread is closing. This is much better, right? The point which I supposed to tell you is that with or without a join, your output is not going to alter much here. I'm just stressing again, guys. In this example, it doesn't gonna alter much of a thing. But when you go with a complex program or when you try to achieve some sort of complexity, right? So you need to be very careful. When you achieve a complex program, you need to be very careful that this join will alter the outcome of your project. So the number of thread you create or the number of thread you run, make sure that you create that much join so that it runs on a same thread without much of a deviation. So that's what it is. So this is the basic example of multi-threading. Okay. Now, what is this? A sequence where two thread is trying to hit a two different function altogether. Now, the same multi-threading can be achieved in a different scenario. A two threads try to achieve or try to hit a one function that I'm going to discuss you right now. Now, see, basically, I just removed function 2. So now what happened? Look at that line number 11 and 12 right now. Both targeting function 1. So now in this case, or even this is a possible case, but the point that you need to understand is that when you try to run this kind of a stuff, right, you can be very careful or you can be very sure that none of the thread will affect the other thread. Even though two threads T1 and T2 is trying to hit the same function, the process of one thread will not affect the process of the other thread. So that is what I'm going to demonstrate here with the while statement. Okay. So during our initial videos, we would have seen a lot of conditional operator like if, else, for, so and so. Now this is while statement. So I'm just incorporating that while here. So now look at that. I'm going to create one counter. Counter is equal to 0. While counter is lesser than 5. Basically, I want this counter to run some number of times, say 5 number of times. So basically, so now I'm going to print the name. So first initially the Dhoni will be coming and then Kohli will be coming. And then I'm trying to print the current time. Okay, now look at the difference. So time dot sleep. Now, if I put some static data like 2, every thread will run with a 2 seconds delay. So just to demonstrate to people that one of the thread will not affect the other thread, I'm going to have different time delays. How do you achieve that? First of all, make sure that you get the delay as a part of the function and use it, pass it via this. So 2 and 4. So now you can be sure that these two is going to have two different seconds as part of their delay. So basically Dhoni is going to have a 2 seconds delay between their 5 thread, and Kohli is going to have a 4 second delay within the 5 thread. So basically 10 number of thread that is going to run within this specific main thread. 5 thread belongs to Dhoni and 5 thread belongs to Kohli. The point here that you need to be very sure is that at times both a thread will run at the same time. So basically what does it mean? It will not affect the other. That's what I meant to say. Okay. So delay, you just put it here. Now you run this code. First, look at that. Both threads started initially at the same time. You know that we've already seen. But after that, look at that. Dhoni prints at every 2 seconds delay, whereas Kohli starts printing at every 4 seconds delay. And look at that. At times, both thread executed successfully. But if you're wondering that why the thread is happening continuously without stopping at the 10th delay or a 10th time, this is because you are not done with the counter. So be careful because consequently, okay, so I see people that they start doing the program but they don't increment the counter. What happens if you don't increment the counter? The counter will remain 0 and it will execute for n number of times. So look at that. So second thread, again it runs both at the same time. Again 2 seconds delay, 3 seconds delay, and then thread stops. So what happened actually here? You can able to achieve what is supposed to. So now what happened? None of the thread will affect the other thread. And also the second thing that you're going to understand from this specific program is that you can have any number of thread pointing towards a single function, or you can have a different function that can be achieved parallelly using a different thread. So these are two different ways of executing a thread. Now, at times, what might happen is that you may have to achieve the multi-threading, but at one point of time within a multi-threading, you have to stop the multi-threading process and then you have to execute few codes in a sequential way. Okay, for example, if I ask 5 people to run in a track event, so what is very important that everybody should start at the same time. That's very important. But when they go there, I told them to pick tokens for themselves. So tokens will be like in the form of numbers. So whoever comes first, they'll be taking the first token and rest of the cases. So in that case, what happened? You cannot have the tokens in a common. So whoever comes first, they have to take one token. So now what I'm trying to achieve here, even though you're achieving a thread, at some point of time, you need to stop the thread to run a threaded way and it should execute sequentially for internal process. Is that possible? If somebody asks you this question, tell them that yes. So I'm going to tell that how do you achieve that? Basically, look at that. So now you know that when 11 and 12 get executed, it will go to line number 4 and both will come to line number 6 all together. So look at that. I'm going to have another function new that is going to have something called token itself, just a variable token plus 1. So you cannot initialize the token. So you need to first initialize outside. In fact, you cannot increment a token like I did at line number 10 without initializing. So I'm just initializing at line number 8. And at the same time, when you want to use the data that is initialized outside of function to inside a function, you know that you need to globalize that. So global token, done. So now I'm going to print like name comma token. So what happened? New will come and it will pick token, it will get printed. So now when I run, both runs at the same time and it picks 1 and 2. So now I may not be pretty much sure that which variable is taking 1 and which variable is taking 2 in this example, because it is still running in a multi-threaded way, that is still running in a parallel way, whatever you call it as. So now I'm going to stop this. Again, if the situation demands where you need to stop a thread at one point and rest of few cases when you want to execute some sequential process, it's like semaphore. This concept is called semaphore. That means even though you run a bigger program using a multi-threading, at times you need to stop the threading you mean to make sure that after that some point of time it should run up one after the other, and then you can continue a thread. So during those case, or when you want to achieve those case, what you supposed to do? Basically, you have to put in a concept called global interpreter lock. Now we are coming back to the cycle one again. What is GIL? When I want to execute, or in fact when program executes in Python, it executes one after the other. Why it is executing one after the other? Because of the sequential process, because of the sequential uh, mechanism that it has by default. Who is responsible for the sequential process that is happening? This global interpreter lock. So now global interpreter lock is something that is available in Python by default, but that is not available when I was executing a multi-threading. Now what I'm going to do? In my multi-threading, again I'm going to pull that guy here saying that, look, I want your help here, so please come and log the program whenever and wherever is needed. So basically I need to take a log. So log is equal to threading dot log. What is this? Threading dot log, lock, and that log is getting assigned to a variable called log. It can be anything. I'm just keeping it as lock. So what do you have to do? Just apply that back as a second argument, because I don't want delay for anything now. So log, you can have the same argument here also. If you want, you can change, but better to keep log for the better viewing. Okay, or else look at that. Here L1, L1, but here you keep it as log for the better viewing. Now what I have to do? When you want to achieve the sequential process inside a multi-threading during this new function, correct? So what you can do is that lock dot acquire. Acquire means put the lock, lock the door. When you want to lock, when you lock the door, what is the next step that you're supposed to do? See, when this multi-threading happens, when Kohli and Dhoni and Kohli runs, obviously they may not run at the same time. So Dhoni would have started minute seconds first, and then Kohli's kick started. So basically, even though you're trying to say that this is multi-threading, there is always a gap. Dhoni started initially with some delay. Kohli started at the last. So now, the moment Dhoni enters into line number 7, the door will be locked at line number 6. So what does it mean? Now, the Kohli, that means the second thread needs to wait for the first thread to complete their operation or its operations. And then what you supposed to do? You have to release the lock. So when I run here, look at that. Now even the alignment tells you the story. Now whatever that's supposed to pass or supposed to get as a sequential way, that is really achieved. Okay, this is what we call it as lock mechanism. So what you are trying to do, we are trying to induce the GIL concept within a multi-threading. As simple as that. Okay, and here the very important thing that needs to be taken is that release. Now what I did was, in my program, I have commented a release. So basically what the code is locked, it is never got released. So look at that. It waits and it waits for n number of times, because it understands that you locked the thread but you have not yet released it. So what you can do? You can release it. So these are all the different ways of achieving a multi-threading. I suspect, or I oddly feel that this is sufficient and enough for you people to get a better of multi-threading. Okay, this is very much important. Now, as I told at the start of the thing, right? Now I'm going to tell you, I'm now going to take you to the difference between multi-threading and multi-process. Whether we call parallel and concurrency are same. Okay. Now I'll tell you the problem with multi-threading. So every system has some CPU core, correct? My laptop has 4 CPU core, and your laptop might be having 5 CPU core. So inevitably what's going to happen is that when you try to do the program on multi-threading, okay, when you try to run the program multi-threading, it runs on only one CPU core. Again, I repeat, it runs on only one CPU core. Okay, so if you try to run 10 threads, so what the 10 threads will do, it will run on the same CPU. I repeat, it is going to run on the same CPU. Fine. Point number 2. What happened that CPU get crashed? That's it. Everything is done and dusted. I repeat, everything is done and dusted. Okay, so you know this problem with this kind of multi-threading, correct? That means what happened? It needs to run without any trouble, and if at all there is any big issue, the CPU crash, that means whatever thread that runs on a specific CPU will get failed. Problem number two, imagine if your program takes a lot of CPU based operation like arithmetic, mathematical operation. Okay, imagine the load that is supposed to take very high. So the moment it takes load high, right, efficiency will get lesser and lesser. When I say efficiency, it means the time that it takes to run a program. Very obvious. So that's the problem with multi-threading. On the other hand, we do have a concept called multiprocessing. Again, I'm going to use the same syntax. Okay, instead of threading, you're going to use processing. Instead of thread, you're going to use process. Here we have at line number 17, 18, threading.thread, right? There you're going to have like processing.process. That's it. That's the only difference. But when you try to run the code on a multi-process, it runs on a different CPU core. For example, if you have a different 5 to 4 CPU cores, what it will do is that it will balance the load among the available CPU equally. So what happened? Every CPU will have a lesser content to be delivered and the efficiency will be very high because the code runs in a different threads parallelly. Now this is parallelly. Okay, so that's one thing that you need to understand at the base, that yes, multi-process is always good that of multi-threading. Why? Because multi-process has a different CPU cores to run its program, whereas multi-threading takes only one CPU to run its program. So load is very high. When the load is very high, the efficiency is gonna get a lot of effect. Fine. Now there is always a term which is very sits close to each other. What was that? Parallelism and concurrency, or parallel and concurrency. If somebody says that parallel and concurrency are more or less same, so I believe that you need to end your friendship right now, right? Parallel and concurrency is very different. Okay, whatever you achieved here is parallel. Whatever that you achieved right now, whatever that you achieved or whatever you achieved in the last 40-30 minutes of video is multi-threading, because when I execute two threads, I already told you very specifically that both the threads runs with the smallest of difference between each other. That is multi-threading. That is parallel. It runs parallelly but not starts at the same time. But what is concurrency? When it starts at the same time, that is what we call it as concurrency. The athletes who runs in a track events, especially 100 meters, 200 meters, that is called concurrency, because they're starting at the same time, irrespective of the result they produce. They were starting. Why concurrency is equivalent to that of, or why I'm just relating concurrency with multiprocess is that now in CPU, in multi-threading, I'm sorry, in multi-threading, I have to run all the thread. For example, if I do have a 5 threads, I'm gonna run this specific 5 threads in one CPU. So what happened? It cannot run all at a time. So it will give some gap between each and every thread. Whereas if it is a multi-process, you know that that is running in a different CPU cores. So in the middle, what you're going to take is that the concurrence is going to achieve here. Everything will start at the same time. Okay. So this is the wider difference between parallel and concurrency. So parallel means there is always a difference between the threads that runs. Concurrency means it always runs equally among the available CPU. This is very vital code, that vital point that everybody needs to understand. Okay. So later, if your time permits, we'll see in some other video with the differences, time differences. What happens when I run the code on multi-threading, and what happens when I run the code without a threading, and with the process and without a process. Okay, and I'm going to demonstrate about uh, input related operation, and I'm going to demonstrate about CPU bound operation. Okay, so I'll be telling which is better, when you should go for CPU bound and when you should go for IO bound. So that we're going to see that in a different video, but make sure that you always get the core out of it. So this is what multi-threading people. Okay, so as you go forward in the future, right, there is a lot of inbuilt stuff that you can learn here, but basically Whatever we discussed as part of this video is very much sufficient, being a rookies or even if you work for the companies. So I told you, right? Maybe in some other videos we might be seeing about achieving the same thing where CPU bound separately and IO bound separately. So if you do come across those videos as well, right, then you will get a lot more clarity. Okay, we'll see that people.